Okay, today we're going to go over properties of similar triangles. All right, strictly just the properties. This is pretty straightforward. We're just going to go over the rules that essentially tell us if triangles are similar or not. Now, there are two major definitions you need to know. Congruent triangles, or in your book it's probably written as figures. All right? And similar triangles. We need to know what the difference between these two words are. So I'm going to ask you guys for help here. What are congruent triangles? Anyone know? Ethan.
Triangles identical in size and shape.
Okay, so triangles that are identical in their size and shape. So in other words, that's the same as me taking this triangle I've just created, okay, and see, check out the word I'm going to use here. I'm going to clone, or I could copy it, but we're going to clone it. So we're getting the exact same thing again. Congruent triangles are identical in size and in shape. Okay, essentially they're the same thing. Now I'm going to use that original one again, so I'm going to copy and paste it this time. Similar triangles. Anyone know what similar triangles are?
Similar is identical in shape.
Okay, so our shapes are the same, but our size can vary. So in other words, I'm going to clone this again, but this time what I'm going to do is I'm going to shrink this. These are similar triangles, and this is exactly what we're focusing on today. Similar triangles. The shapes of them are the same, but the lengths of each side, okay, are not the same. We're going to talk about what needs to be the same in terms of to have a similar triangle. Okay, so we're going to use these two again. Clone them. Clone the both of them. Okay. So these are two similar triangles. Their angles are the same. So we'll call this triangle ABC. And we're going to call this DEF. And what we're going to discover is, since this is a clone with just the side length shortened, all of the angles, so angle A, B, and C, are the same as angle D, E, and F. Now, in your book, a lot of times they write an angle using this notation where, for instance, if I were to say angle A, B, C, does anyone know what angle in the triangle I'm actually referring to? Yes, that part B. What they're doing is they want you to draw or highlight a line from A down to B and from B to C. So in other words, they're highlighting angle B. When you get something written like this, we're essentially just focusing on the middle letter. Okay, they write it like this, and a little later we're going to write them just as single letters, so I'm going to get used to that. I just want to show you this so you understand the textbook, and then we're going to get used to writing it as just one letter. Okay? And if that's the case, angle ABC, what angle in the other triangle is angle ABC equal to? DEF, that's right, angle DEF. Essentially, angle B and E are the two that are the same, right, when we refer to it. They're both, looks like 90-degree angles. But because of the way they write this, it is DEF. Now, what if I were to say angle, it was also equal to angle FED? Is that correct or incorrect? Correct. It's the exact same thing. All they're doing is starting at a different point. Remember, they start at this point, come down, and come up here. We're still making that exact same angle. Okay? So both of those are fine. Whether you write them with the first and last letter interchanged, they're both the same. Just make sure our middle letter is the same for the textbook. Okay? Okay, with that being said, we're going to talk about actually naming triangles. So, if I've given this angle A, this angle B, and this angle C, we're going to talk about naming the sides corresponding to those. So, angle B, in this case, side B will be opposite of that. Okay? Now, I know you're used to Pythagorean Theorem where we call that C, but let's just say we're naming the triangle in general. Okay? Side B is opposite of angle B. Side C will be opposite of angle C. And what does that mean for A? It's going to be opposite, right? Okay. So, with that theory being said, what side of the triangle am I on right here? Hold on, I'll highlight it so you know what I'm talking about. What side of the triangle is that? E. That's right, good. Write that down. What side of the triangle is this? D. Good. We'll write this down. And that leaves the other one to be, great. Good. We got it. Okay. So now that you guys understand that idea, the angles in these triangles are the same. The distances of their lines are what are different. Okay. Another very important part of this is that the ratio between sides are the same. And that's how we're going to essentially answer questions. Okay? So I know we're just using letters. We're eventually going to get into using numbers when we're getting involved in this. A lot of time in the book, another thing they'll do is when they name a side, they'll call something side AB. Now, personally, we're going to refer to this as side C because it's opposite of angle C. But in the book, they usually use two letters, two endpoints to denote it. So we go later on into trig. I want you guys to get used to what I just showed you. Just one letter for the name of a side. Uppercase for the angles, lowercase for the sides. Okay? So, in other words, what they have here is side AB, they'll say this in the book, divided by side DE. Okay? These are sides that are considered the same. They're on the same parts of the triangle. Okay? The ratio, if we were to divide them together, is the same as side BC divided by EF, which is also the same as side AC divided by DF. I want to show you what we did there. This was our AB and DE. So those were the sides we denoted with the red. These are BC and EF. And these were our DF and AC. Okay? So the ratio of these in similar triangles will all be the same. And I want you guys to keep that in mind when going to solve something. So we're going to make up a triangle here. Two similar triangles. Clone this. We want it to be similar of a different size. We'll shrink it again. So if I were to tell you that this triangle, actually I'm not going to name it. I'm just going to tell you that this is 15. This is 20. And this is, let's make this easy. 5, 3. Actually, 5 is a much easier number. Let's do that. Okay. First thing I want you to do is actually name this triangle. Okay, so what do you want to call the first triangle that has two of the measurements? ABC? Sure. Here's A. Here's B. Here's C. Great. Now with that, I got to name that similar triangle. What do you want to call it? Is that? Okay. Here's going to be my D, E, F. What I've named this, does it really matter what order I put the letters in right now? No. Just order of how we put them together now. Remember, I wanted you guys to get used to this. So, if this is C, what is my side C? 20, okay? That's going to be our side C. If this is angle A, what's going to be side A? 15, good. And B will be the unknown. Side E will be 5, great. D will be unknown, and F will be good. We've gone opposite of the angle. Good, good, good. I like that you guys got that. So, in other words, what we're going to do now is we're just going to use one letter. I know we used two before. We're going to use one letter to put these together. So, someone give me a 3-set ratio with this triangle. Just the way I've done it up here, where I had AB divided by DE. How can I do that with just one letter in each of them? Anyone help me out here? Nah. Okay, so A divided by E, good. Those are corresponding sides. Equals
C divided by D.
C divided by D, good.
Equals C divided by D plus C. Is that?
B divided by,
Is that an F?
that's an F. We'll just keep it as an F, okay? So, there's two things that Mac did. He stumbled and he went back. He did a good job of this. First of all, what he did is we're going to highlight this triangle. We'll call this triangle in yellow. If you notice, all the letters or we didn't use numbers yet, but all the letters are on the top. When we're setting up the ratios, we have to make sure that the sides we're referring to are all on either the top or the bottom of the ratio. And the triangle FDE, okay, we got to make sure that all of those are at the bottom. Okay? And we've set them up so that they are corresponding. Like we had, this was B, this is F. Well, that makes perfect sense. There's our B and our F. This was side A, this was side E. Perfect. We had A over E. And finally, we had C and D. Great. We had C and D. So that works out great. That ratio works. We've set it up properly. The yellow triangle sides are all on the top. The green triangle sides are all on the bottom. And we had the corresponding sides divided by each other. I could have flipped this. This is also the equivalent of E divided by A, D divided by C, and F divided by B. Okay? I know we're using letters. This is getting a bit confusing. Let's plug in some values and actually solve for the other parts of the triangle. So first of all, side A is what? 15. Good. 15 divided by, what is side E? 5. Good. So we have one ratio. That's going to help out. We do need to have one ratio in order to solve this. What is side C? 20. Side D? Unknown. And side B? Side F. Okay. I want you guys to talk to me here. What can we solve for to start? There's only one variable I can solve for. B. Not B. I got dyslexic for a second. That's a hint. D. We can only really solve for D right now because I have one of the sides that corresponds to this. Okay? I have information. We always set it equal to the one that we have all the information about. We have all the information about A and E, 15 divided by 5. I have no information about B and F, so I can't really do anything to solve this. Right now, we're going to break this into one question. We have 15 over 5 is equal to 20 over D. Well, I'm trying to isolate for D. What's the fastest way to do this? Cross multiply. We have two equal fractions. So we cross multiply. I'm left with 15D is equal to what? 100. How do I solve for D? Divide both by 15. D is going to be equal to 100 divide 15. What is it? 6.66. Okay. 7%. Okay? And rounding. So, that side of a triangle, D, so we go back up, is 6.67, we just figured out. But how do I go about solving B and F? And I've denoted something here to help us out. Okay. Because this is a right angle triangle, so I'm drawing on something that it's not technically taught here, but you're supposed to already know. Because this is a right angle triangle, we can use Pythagorean Theorem. If it wasn't a right angle triangle, we wouldn't really know how to solve for that side.
Sure.
Okay? We would be at a loss for that.
Sure. Kind of like
Because we do know Pythagorean's Theorem, I can solve for either F or B. And I can use Pythagorean's Theorem to solve for both, or I can solve for one and then use my equivalent ratio to solve for the other. Both are fine. We're not going to go through it. I just want you guys to know that you could do that. You can use Pythagorean's Theorem to solve the rest of this question. Okay? So we've gone through quite a bit of stuff with similar triangles. That's all it really is setting the ratios up. That's the hardest part of this. Okay, so we'll go through Pythagorean's Theorem, which is a squared plus b squared equals c squared. I'm going to quickly draw our triangle. We had 20, 15, and an unknown. Okay? We're going to call this B. I think it was named B. All right. Well, if this is A, in Pythagorean's Theorem, we must always call the hypotenuse C. It just so happened we named the triangle that way. If it wasn't, you would have to rename the triangle. C is our 20 squared, A is our 15 squared, and B is our unknown squared. 20 squared, 15 squared, anyone know off the top of their head? It's 225?
Yeah.
Is that what it is? Okay. 225. I need to isolate for B, so I bring 225 to the other side of the equation. We get 400 minus 225, which is 175, I think. And then we need to square root it. I don't know that. It's 13 point something. 13.22. Perfect. Okay, so now that we know that this B is 13, don't worry, we'll go back down, 13.22. I can easily use Pythagorean Theorem again to solve this, or we can use our ratio. Either of them will work for this question. Okay? That was a quick recap on Pythagorean Theorem for you.